Greetings to you all and welcome to this session. I would normally take a minimum of 40 hours to cover a programming language. Assuming we spend 1 hour every day, that means it would take approximately 1.5 months to complete this course, which also means we are going to have approximately 80 videos for this language. That also means you're going to commit some quality time. So before I continue with the topic, let me share a few tips on how you could make the learning more productive for yourself. Taking notes has been very helpful for most of my students. Maybe you will never go back and look into the notes, but please take a notebook, pen, and start taking important notes as we go through these videos. Avoid distractions if your TV is on or if you're listening to any news or broadcast in your mobile or radio. You would be better off by switching them off. And as we go through one topic after another, if you can visualize the important concepts with something that is very close to you and you can visually model these topics, then it will give you a recall factor and it will be very helpful for you to remember these concepts at a later date. In fact, me, as I go through this program, when I try to explain some of the important topics like OOPS concepts, I would myself be using some of the. If you think you've been spending so much time and few of the topics are going above your head, you probably are bored by now, so you should stop, continue watching this video for the time being. Go back, relax, do something else important. After a few time, you can come back and continue from where you left. A very important point is applying what you have learned. Yes, I'm showing some code in the videos here, but unless you practice, you will never master the technology. Watching a person driving a car doesn't make you an expert unless you actually do it yourself. To help you do that, all the examples I'm using in these lessons, I'm sharing it with you in GitHub. You can go to my GitHub repository and you can download this code. The URL for GitHub is available in the descriptions in this channel. Please make use of it. In addition to that, I'm also planning to provide additional content in form of solved solutions to problems and additional assignments. And even in fact, I'm planning to use MCQs. Feel free to drop in a mail to me in the mail ID provided here in the descriptions. I've had some feedback that people say I speak a little bit slower. That I'm doing it on purpose because freshers and people who are not very familiar and strong in English, they would find it difficult if I speak pretty fast. But obviously you can use the playback speed that is available with YouTube, and you can increase it by a few points like 1.5 or more, and you would, if you really have mastered a technology, then following the Feynman technique would be very helpful. That also gives you an idea about how well you know this technology. So this is a well time tested steps. Please put an effort here. You can actually teach whatever I'm sharing with you with your friend or your brother or any other junior students in your college. We have discussed in the previous session about computer programs. Technically, it is just an electronic file that consists of functions and methods, and each function and method would consist of instructions. These computer programs, we discussed that they are in high-level human-friendly code, and if in order to execute it on a computer, it needs to be converted into low-level, that is a mission-friendly code, and some languages would use a compiler to do that job for us, and some other language would use interpreters. Now coming back to functions or otherwise methods in Java, a method is a collection of statements that is trying to perform a particular task. They get sequentially executed. So these group of instructions together perform a task. Now if you write a method with say 100 lines of code and end up copying pasting a few lines of code multiple times in that particular function, then you are literally repeating yourself. You should avoid copy paste of code, and maybe these lines of code can form a separate method on its own. Please remember the term dry. Dry stands for do not repeat yourself. So if you're copy pasting few codes, then you should think of moving it to a separate function. A method can be called from another method and thereby making it reusable. So that which means you could avoid copy paste. One of the important factors of functions or methods are that they are reusable. In fact, remember we discussed the term public. So if you add a method or make a method as public method, then it's not only reusable within the same class, but it can also be called across from another package. So remember, each method is a block of reusable code. Variables, another very important point in a class. When we go for campus drives, I have been surprised students in the final year not being able to explain what a variable is and different types of variables. So every single slide in this presentation and every point shared here is important, and anybody who's coming in for a campus drive would expect you to be thorough on these topics. You can't afford to forget it and just say that you learned them in your first semester and you don't remember them anymore. Please make a note of these points. These are very fundamental points that I'm sharing in these slides. A variable is a name given to a memory location during runtime. When you enter data into your mobile app or in your browser, those values are actually stored in variables. The variable is used to access those values and to further manipulate them if necessary. Working with variables. Look at this block of code here. We have declared a variable by name x. We have also defined that the variable data type is int. More about data types in the next slide. We are storing a value 5 in the memory location which is named as x. Then we also change the value of x from 5 to 3. The third line, when we try to execute x plus equal to 10, what we do is end up incrementing the value in the memory from 3 to 13. Let me demonstrate that piece of code using Eclipse. Yesterday, I demonstrated how to create a project. We named the project as Java Basic Lessons, and we have named our first package as com.lessons.day1. So today I move on to creating a second package by the name day2. So you can notice I have named my package as com.lessons.day2 and I've created a class called DataTypeDemo. Now this is the sample code that I've shown in the slides. Method A, and we have variable x with the value 5 initially. Then I'm displaying it in the output screen using system.out.println, where we have seen in the first exercise itself that out is an output stream and println is a method that will display whatever content is passed to it as a parameter. Subsequently, we're changing the value of x to 3 and then again printing it, checking whether the change is successful, and increment the value of x by 10 and see whether that increment also works. Now I want you to focus in the main method. If you notice here in the main method, it's completely empty. And I have two methods here. One is the main method and the other is, so here the first method is the main method and the other is the method A, which I have just included. There's an error in that code, a convention error, that the M in Java, any method, name of the method should be in lowercase in Java. So I've rectified that error. It is method A with M lowercase. I need to call this method from main so that this can be successfully executed. So I go into the method block of main, and from there I just call the method, and that's it. Now main method is static. A static method can call any other static method without an object reference, and as a result you can see directly I'm able to call it. And I don't need to use the class name because both these methods belong to the same class. If method A belongs to some other class, then you need to give that class that other class name dot method name. So now that we have the code in place and we have made the call, so let me run the code. Go to run as Java application, and now Eclipse should compile it and run it for me. See, notice we got the result. Data types. The amount of information the average person deals with on a daily basis is mind-boggling. The knowledge discovery and data generation through research and business activities are, in fact, doubling every 9 months. Luckily, computers have come to our rescue. Unlike humans, a computer requires well-defined metadata about the data in order to store, process, and manage them. Value that we store, manage in a computer are mostly numeric in type, and they could also be characters, alphabets, symbols, and could be just a Boolean value, true or false. Numerical data that we use in our software normally vary in size, and they will have to be exactness is about precisions, the decimal points. Let me give you a few examples to enlighten about the complexities that we are working with when we handle numbers. Take for example the degree on your home thermostat, or you try to represent number of stars in the sky, or the amount allocated in our country's national budget, or just simply the amount of salary that you pay to an employee. Now these are 4 different examples where we use numbers to represent them, but the range of value for each of these are not similar. They vary from one another, and hence I would need to handle these data different from one another. Each of these numbers in this example have different ranges. They illustrate the property of the numbers referred to as the size of a value, or however small or big they may be. The range size of the numerical value required in a computer program to make calculations for solving a problem determine how much memory would be allocated to store the value. If you count the coins you have saved in your piggy bank as say 597.45, then it can be expressed in about say 5 digits of precision. That is 3 digits for the numbers 597 and 2 digits for the decimal point 45. Whereas for the value of natural algorithm, 13 or more digits of precisions are required. Earlier on we have discussed about range or size of value, and now I have given you a couple of examples for precision required for numerical values. So computer programming will have to consider the range of a number as well as the precision required for each number while allocating memory for it. A programmer, as he designs and writes a software, they select from these well-defined data types for the problem at hand, and these data types that is selected by the programmer indicate to the computer through the statements that they write how you want the computer to process this data. The selected data type determines the amount of memory that would be allocated for a given particular statement. Most of the languages support 8 primitive type data starting from byte, short, int, long, float, double. These are 6 numerical data types, and they have 2 other data types, one for representing Boolean true or false, and finally you have a character data type that you could use to represent any one of the symbols. In fact, alphabets and even numbers can be stored as a character. In this code example, demonstrating usage of data types, I have declared initially 2 variables x and y, and I've declared them as int, so I can store numerical values to it. And then I have also declared a variable s1 and s2, to which I have assigned the same value 10 and 20. But remember, these are strings. You will have to put your data within double quotes for strings. Now, how a computer handles these 2 numbers when they are integer, and the same 2 numbers when they are a string, is what is demonstrated here. If you notice, I have initially trying to add x and y, and the plus operator is used as an additive operation here, and I would normally get an output as 30. 10 and 20 are added with each other, and I get an output 30. But now the same value 10 and 20, when assigned to a string, the plus operator, instead of adding these 2 numbers, performs a concatenation. The metadata available for the data type string tells our runtime how to treat these 2 values 10 and 20, and instead of adding them, it gives me a concatenation operation. The same concatenation you can also see when we use with S3 and S4. Hello in S3 and have a nice day in S4. When concatenated, it forms a single string, providing as an output hello, have a nice day. Let me demonstrate it and show it to you in Eclipse. So I go back to the demo we've been working on earlier on, and method A is the code that we were using earlier on for the first demonstration. So now I move on to method B. This is where we have the code for the current example. So you notice I have used x and y here, the 2 numbers, and the value 10 and 20 is assigned. So when I execute it in my output stream console, I would have a result 30. The same value 10 and 20, when stored in a string, I would expect 1020 to be given as an output in this case. And concatenation should happen between S3 and S4 also. For this to execute successfully, it needs to be called from main. The starting and end of your code execution is from main. Any function that is not called from main will never get executed. So instead of method A, I will call method B there. And now you can notice method B is being called from main. And let me run this code. So on execution, you notice initially x plus y has given me an output 30, as you can see in the result, and s1 plus s2 has given me a result 1020, and s3 plus s4 has given me a result hello, have a nice day. So that's the demo. And now moving over to the next topic, method parameters. In the adjoining source code sample on the right hand side, you see two functions, two methods, f4 and bar. 4 has two parameters, I and f. The data type of I is int, the data type of f is float. Float is a decimal, you can store decimal points, fractions in it, whereas int is a whole number. 4 takes two parameters, whereas bar does not take any parameter. Both are void methods. And if you're trying to call 4 from bar, if you notice in bar, in this particular line, we are calling 4, which is technically you are calling 4 method from this particular point. The value 1 that is assigned to an int, that is the name of the variable, will be passed to I, and the value 2.0f will be passed to the second parameter of 4, which is f. So it will get executed and you may get the necessary output. A very important point here I would like you to note down is I and f are two variables which are scoped local to 4, which means they are visible and accessible only to 4. You can access these two variables outside 4. And the data 1 and 2 that we are passing from bar are called as arguments. The data that is passed as value to a method are called as arguments, and the variables declared as input for a function or a method are called as parameters. Let me demonstrate this code by showing you in Eclipse, and I will execute the code as well. Instead of method B, here we can see at the same class I have a static method called 4 as well as bar. Now in bar we are actually calling this method 4, and that should in turn execute the 4 method. The value that I'm passing 1 here should become the value for I, and the value I'm passing 2.0f should become the value for float. So when I normally pass 2.0, Java JVM takes all decimal points by default as double, and hence you will have a data conflict with the signature of the method flow, wherein it is expecting the second parameter data type to be float, not double. So if I just type 2.0 without the f there, then by default the compiler will take it as double, and there will be a mismatch with the data type of 4 method. And Java is a very strongly typed language. So even though double and float are kind of similar in nature, it does not accept this. So you need to explicitly denote that this value is in fact a float and not a double by adding this f at the end of the number. So now it's clear that you're telling the compiler, hey, treat this 2.0 as a float and not as double, and then it gets passed to float. So when flow is executed, I would print that on my console, and subsequently the method execution for bar will be over. Now I need to call this bar from main. So notice when I execute this code, first main will run, main gets called, and main in turn calls bar. So what will bar do? It will first create a local variable called anint, assign a value 1 to it, and then subsequently it will call 4. While calling 4, it will pass the value 1 as the first parameter, and then it will create a number 2.0 as float and pass it as a second parameter. And now the focus from bar goes to 4. The method 4 is loaded into memory, it is executed, and output stream prints the data, and after that 4 execution is over, and the memory allocated for 4 is removed from the memory. It's no longer required, its execution is over. So the variables declared in for and the memory used by the method for is no longer there. It has been flushed out of its memory. And now the focus comes back to the bar method. And since we don't have any more additional lines of code inside bar, so eventually the code execution of bar also comes to an end, which means the variable and memory allocated for the bar method, particularly if you notice this local variable and int with the value 1 and a memory for this value 2.0, that would be there in the memory as long as bar is running. Now that the bar function execution is over, so this memory will also be reclaimed, removed, flushed from your memory, and now the focus goes back to main. And as we see here in this code, that bar is also happens to be the last line of code in the execution. So main ends, and with that the code also exits, JVM shuts down, and we are out. So that is method parameters. Methods may have, it's not compulsory, but can have parameters. In this example, that int I is a parameter and float f is also a parameter, and the value that is passed to them are called as arguments. Right now I've only discussed two types, a particular type of method with void as its return type. So you can call a method, but it doesn't give you back anything. It can take input through parameters, but it doesn't give you anything as an output. Now if you're looking at a function that should return back any data to you, for example, I'm trying to pass a number, 2 or 3 numbers, and I want my method to process the data, add them, and give me the sum of those numbers as a result back to me. So in that case, you can provide a return type to your method, replace the void keyword with the return type. So in this example you see on the screen is that you're taking a number as an input, you're adding a value 10 to it, so it gets incremented by 10, and so if I'm going to pass a value 5, so the result that will be returned to me by the total method will be 15. So method can have return types. After processing the data, the method can return the result value. One important thing that we need to observe here is, if a method has a return type, then the last executable statement of the method must be the return statement. And the data type of the return statement, the data type of the value that is being returned by the method should be the same data type that is defined in the declaration of the method. Let me give you a simple. I have a method called add here. Add takes two inputs, x and y. It will add these two numbers, store it in a result, and return this result. The result that is returned is nothing but the return type we have declared here in the add method. So if I call add, I would need to pass two numbers to it, and these two values will be received with the add method. It will process it and return as a result. Let's see how to call it. Because I need to pass two values to x, so I declare int value for x is equal to 100, and then int value for y equal to 200, and after that I would like to have another variable, name it as result from add equal to, I'm calling the function add by passing the two variables, value for x comma value for y. So what will happen here is, first a variable called value for x will be created, another variable called value for y would be created. Normally by default all numerical variables will have a value 0 allocated in memory, and as I assign 100 to x. So 0 will be replaced by 100 and y will have a value 200. Now I am calling the add method. So now 100 and 200 will be passed as input to add method. So the value of x in add will be 100 and the value of y in add will be 200. Now the focus goes to line number 44. X and y gets added. The result is stored in the variable called result, and then it is returned. So once the return result key statement is executed, there's nothing much to do in add. So from memory, the entire from stack, the entire memory allocated for add and the variable is all removed, but the focus comes back to 8. The result returned at line number 45 will be now stored in the variable called result from add. That's in line number 8. So I repeat, whatever is returned here in line number 45 will be stored in this variable in line number 8. Now let us print the result. And run it as usual, run as Java application, and I got the result 300. So that's about return types of function. And functions, as we already know, can be void. Technically, void is not a data type. Void is a placeholder, a keyword used in our language, which acts as a placeholder to tell your runtime that, hey, this method does not have any return value. So these methods that are void can be used to perform some operations on this application, but doesn't return any back to the caller with any value. It takes input, it can take input, can process the data, but they would not return anything as an output. We have already seen the demonstration for void methods through for and bar. We also seen a demonstration for using return type. So with this, I will end this particular video. A quick summary of what we have seen. Few tips about how to remember what you read or learn. And we discussed about methods, variables, data types that we can use for declaring variables, and the parameters that you can pass to methods, arguments that are assigned as values for parameters, methods that are void, and methods that have return type.